Thanks everybody for joining. Hopefully we can get some useful information that will help anybody who's thinking about how to take operational data and use it. So I'm Marvin Tansley with ThingZero. Also joining me,
Aaron Pfeifer with Atlas OT.
Great. And the reason we kind of put this together, Aaron and myself, was that we're two sides of the same coin, which is the OT side of it. And, what is the expertise and capabilities, really of Atlas OT? And then how does that work together with what ThingZero is doing? So if you want to take some time to kind of talk about how you help clients and what your objectives are in working with them, then that'd be great. And I'll jump in as well.
Yeah, so Atlas OT, operational technologies, right? It's in the name because that's what we do. We really focus on inside the firewall, inside the fence line, if you will, depending on the facility and how you measure your assets. But everything from instrumentation, controls, electrical, we'll do some of the engineering, design, procurement, programming, and field services. That's really where our bread and butter is. Our team, we not only help on the capital projects to get these new facilities or these brownfield facilities revamped and redone, but our team really works with operators on site, in the trenches, supporting and keeping these assets up to date. So I always like to say we're CapEx conscious, but OpEx optimized, because our team is both living it side by side with the operators, but then also implementing on those capital projects, whether it's architecture of control systems, electrical design, instrumentation, just optimizing those facilities the whole way through on that control side.
Yeah, perfect. And that is, a real area of expertise. It requires you to go to the field and get your trucks dirty, as I guess, and then. From us, from Marvin Tansley at ThingZero. So ThingZero stands for the Internet of Things and Zero Trust. And so when we combine those together, we understand that ThingZero helps combat Thing 1 and Thing 2, which are chaos, if you're good on your Dr. Zeus. And so our side is sort of looking at how do you move the data effectively from the fence line, understanding that, you may have a cell connection, you may not have cell connection. How do you best operate and pull that data up in order to do predictive analytics? And so predictive analytics is a pretty broad statement in category. When we look at it as how do I create better operational efficiency from my systems? How do I predict things that cause failure in systems, or predict things when I need to do maintenance prior to reduction of either utilization or dropping productivity of systems? So we like to start everything really in an ideal world. In all the years I've been delivering projects over the years, it's great to start with the strategy, and the strategy doesn't have to sound like too sophisticated. It starts with what is it you're trying to achieve? What are your regulatory requirements? What is your management process? And what do you need to sell up into your management in order to get this project approved and pulled through? And then what does it take to test the concept, deploy the concept, and then run it afterwards? So it's the full kind of end to end, and taking you very much in an agile development process. So I know, Aaron, you've talked a lot about it, that a lot of data is existing already in a lot of these systems you're working with. So how do you talk a little bit about that, and what are the pluses and minuses of existing data systems?
Yeah, well, and I guess before I really jump straight into that, I have to say too, one thing I do enjoy about working with ThingZero from our aspect anyways is, we've gone into facilities before where there's always that IT guru that just says we can pull in the data and we'll pull it from the magic white space or whatever. And then we find out they're just pulling it from from spreadsheets or from hand-drawn notes and operator inputs that are all garbage or whatever. And, one thing I do enjoy about the ThingZero aspect is you guys actually understand the data is there. It's in the PLCs, it's in the SCADA system. That's real data from the machines. So, they'll steal. I know this isn't the intent of the zero trust environment, but that's more cybersecurity. But we're pulling it from the machines. We're getting the real data to then do a real, ROI on that. But to your point, Marvin, as far as, the data, it is there and everything is, a lot of these facilities, they have PLCs, whether you're talking manufacturing, whether you're talking oil and gas, you're talking water and wastewater. There are these specialized computers on facilities that a lot of executives have no idea what they are and that they exist, but they're the machines that actually operate these facilities. They turn them on, they turn them off, an emergency, steady state, all of that kind of a deal. And they're already collecting a lot of this data, right? And so it is real data from a machine counting cycles, right? And we can inference that the cycle means a pallet or a object or a barrel of oil or something along those lines, right? And so that data is there already, and it can be optimized, it can be improved, it can be, cleaned up on site. But then there's some of those bigger, higher level things that, you guys are going after, which is, well, what if I want to look at 10 of these facilities or 20 of these facilities, or look at it over the range of several months? Where are some of those inflection points? Where are some of those opportunities? And so we've seen a lot of success with when we work with the executive teams or the district managers, if you will, that do care about the larger operations there. How do you find these little areas where you can find a 1%, 2%, 10% increase in production? And it adds up to real dollars, right? It's instant ROI, as I like to tell a lot of people, because a 3-month project for us might pay for itself in 6 months or less for some of these facilities once they know where the bleeding on some of that stuff is, right?
Yeah. I think you brought up 2 things there, 3 things that really triggered different, conversations for me. One is, I worked in manufacturing for a while in Kentucky and then later in Europe. And, the people who run these things, they know what they're doing, for the most part. They've been there for a long time. They understand it. And, the real magic comes when you get out and ask them, hey, look, I've looked at all of the operating facilities, and your facility's running at 98% or 96%. Most of our facilities are running 70, 80%. What the heck are you doing? Can you tell us, right?
Yeah.
And you find out that, again, in manufacturing, we had this one place I worked in Kentucky. They had, poor output. It was like in the, high 80% range. You think of it, that's quality output. So all the rest of that's rework, right? And when you're selling stuff that are like, it's a commodity product, those percentage points make the difference in market share, basically on every percentage point, right? So getting to the people, understanding the process, and then you say, okay, how do I get all of my other facilities to operate up to that level?
Right.
And the operator is going to tell you about this data and that data, not in data. They're going to tell you about when this happens, I know that happens. When I see a pump vibrating, I know it's ready to go. The bearing's happening or something.
Right.
And that's when you say, okay, here's all the data. A lot of this data isn't even pieces that we're measuring. So we're going to have to retrofit in some sensors for vibration or heat and temperature, whatever it is. And then we're going to collect that data. We're going to build a model and say to the operator who's running this facility at the high level, here's a prediction that's going to happen. What do you think? And he's like, yeah, that's right. Or she's, yeah, that's right. Or no, I have no idea what you're talking about. And then who knows, maybe a month later, it fails. And they're like, wow, the predictive model actually predicted it before I could sense it, And so this is where, that's what I'm saying, kind of the real magic. But your point about trust, zero trust around security, now with modeling and everything, you need to make sure your data from the point where you get it all the way to where you're going to analyze it isn't having, because an attack point now becomes injecting false data into the system.
Yeah.
that would force, say, like a shutdown.
Right.
Because now when I start automating my systems all the way back to the PLC controller, it's saying, I'm going to shut something down.
Yeah.
You can force that not by sending a shutdown command, by injecting false data into the system to make the model shut it down.
Well, to your point, COVID changed a lot, obviously, right? But definitely pre-COVID, there was always the phrase of air gapped, meaning that your control system is not plugged into the internet. And I would definitely say, as macro chapters of the world, pre-COVID, that's a relatively fair statement. Nobody was plugged into the internet, or they weren't intentionally plugged into the internet. If they were, they did have that pretty well isolated and locked down. I will tell you firsthand experience as, a company that focuses on the on-site critical repair and on-call support and 24/7 answer call service, that kind of thing. That changed right after COVID because the trade-off people had to face was, do I allow somebody on my site with a face mask and with or without a vaccination, pre-vaccinations especially, right? Do you have a whole new workforce and safety policy around that? Or do I go ahead and the lesser evil, just put this on the internet and they can remotely access it and I don't have to deal with them being on site? And the reality is since COVID, I would tell you, I would be shocked if not 90% of all critical infrastructure, manufacturing, et cetera, are at least in some capability already on the internet, whether it's directly, indirectly, whatever. And I guarantee you somebody is screaming at the screen right now saying that's not true. Our facility's not. And let me come out. Let's do a check, because I might be wrong. I hope I'm wrong. But if you're not, then, I've gone out in the last few years and we have found PLCs on business system networks. And yeah, if you know how to IP it, ping it and find it, you can hit it, access it. You could do a network storm and take it right out. Right.
Yeah.
And, obviously you don't want.
No, you're so dead on about that. It's like we had a large client that ended up getting hacked just because somebody went and stood a router up in their data system for a Wi-Fi repeater in their data center.
Yeah.
Opening a full door to their data center.
I'll give you one worse. I literally got an email from a customer once that in it had a spreadsheet, and in the spreadsheet had all the IP addresses for all their facilities. I clicked on it from my work internet, way states away. I could access their systems, 100% access their PLCs and systems. Not even I could have hit the shutdown button, right? It was that bad. And people just aren't aware. They don't see the reason with that. That's kind of terrifying. But, the zero trust piece here we're trying to talk about today, get that data, get it into the systems, democratize your data, get it in front of your executive staff and do it cyber secure, zero trust. And the reality is you can do that. You can make it read-only data. You can make it a one-way direction, at least to begin this exercise in seeing and finding the predictive and finding the commonalities, use those large language models, however you're doing it, to find the optimizations, right? So it's funny, but it's also terrifying. And so when you're looking at this, we do want to apply it in a best practice. We want to do it with whitelisting. We want to do it with, serial communications, which are not Ethernet communications, and therefore you can't IP and ping and hit. And there's smart ways to do it and still get this information in real time to your executive team. And that's, I think, another big piece that I've been on a soapbox for a while about is if you go talk to an executive at any company, the question is, hey, can you tell me which facilities are up and running and what their efficiency is? And if they can answer that question, they'll say, well, let me go get the production report from last quarter and I'll tell you. Well, last quarter only does you so good. If I can see it in real time today, I can help people put a dashboard on their screen. And we've done this where they can see of their 100 assets that they're looking at, green, yellow, red, in terms of production and expectations. And the ones in yellow and red, we probably need to address. And maybe it's shut down for a turnaround today, and that makes sense. But why is it shut down? You're talking about predictivity, and there's productivity as well, or predictions to predict why a facility will be shut down. And if you can predict that, now you can say, hey, this one's going to go down. These ones need to go up. And now I can make more production, or I can hold production, and for how long, and all of those different parameters. And that's just basic operations. We're not even talking about really getting into, the weather is changing and therefore my tanks are going to overpressurize at a higher amount. So I should probably lower production to keep them from overpressurizing and having an emissions event, right?
Yeah.
Which opens the conversation.
Right? For sure. and same with paraffin buildups and all those type of stuff, right? A lot of that, I always think of it in one of the really good books that I read about, IoT stuff was, look, my wife owns a Jeep, and so she drives it back and forth to work like 5 miles from here. And at 5,000 miles, the oil looks the same as it's not even close to being right. Now, imagine that same Jeep, you live, out on a ranch somewhere, and you've got a gravel road you're driving back and forth on, and, you've got a lot more contaminants in the air environment and all the rest of that. It probably needs to be serviced at 3,000 or 4,000 miles, right? So to me, predictive analytics is about how do I optimize when I do something, right? And so you start by, getting all the data, and then you start by saying, okay, so what were the maintenance events we saw that were shut down? And we're just going to Pareto analysis this and say, what are the 20% of the things that cause 80% of this, right? And, do I have some, aluminum heat exchanger that when it goes down, it takes a year to order? How long do I end up shut in for while I'm waiting, or just running on the secondary unit and hoping it doesn't go at the same time as the primary unit, right? So these are all these where you understand the criticality, and you understand how long, what the impact is, measuring the impact of that. And then now I say it's worth measuring because the impact is great enough that will give me the ROI by having, longer operational periods.
Yeah. What's funny about that? That reminds me of, in a past life, I've done cell level analysis for safeties. It's safety instrumented levels, safety integrity levels. And what you're basically doing is you're saying, okay, a SIL 1 is 1 out of 10, a SIL 2 is 1 out of 100, 1 out of 1,000, right? And based on that criteria, this will fail 1 in 1,000 times. We need that level of integrity. We need that level of confidence for a shut-in. And so on some of those projects, we're talking about 48-inch valves that are the inlet for a major refinery or something along those lines. And so we would do the calculations to say, okay, if we use these instruments that are rated to this level and multiply them by, this valve multiplied by this and this type of controller, we're looking at the failure rates of the equipment. But then another part of that is also, what's the maintenance schedule? How often are you maintaining, and how often are you changing out filters? How often are you doing these things? And ultimately, the deliverable, was, yes, do we have confidence this is going to work correctly? But part of it is, how do we maximize production? And so what we were doing is partial actuations on valves, because if we could do a partial actuation, we could prove the system worked without shutting down the entire facility. And now we could do these partial actuations maybe once a quarter and still have production unaffected largely, versus, and now we're doing a shutdown once every 2 years, opposed to a shutdown and a full turnaround every quarter, every year. And so maximizing so much production through a 48-inch valve with oil at the time at $100 a barrel. It was a no-brainer to go through and say, hey, how do we maximize these things? To your point of dirt road versus city road and everything else. Well, if I only have to go get an oil change every, twice as often or half as often, then how much does that make me just in a week of safe turnaround time that I don't have to pay for the labor and all of that to do things that aren't necessary? And when you can collect that data and you can compile it against all of your existing assets already, you've got a huge pool of data here. In many cases, whether you're historizing it or not, you've got real-time data at a lot of facilities that you can be looking at the same time. And if you were historizing it for the last 10 years, now we can go back and we can look at all of that data and really see what was hitting, what was working, what wasn't working. Why is this facility at a higher production than these ones? Was it the maintenance cycle? Was it the manufacturers that we used and the equipment?
Yes.
Was Emerson or Roanoke better than Vega? Was, Anderson Hauser better in this situation? Or, maybe it's just that specific instrument, the way it was installed, right? That's the stuff that gets interesting to start to analyze with those data sets, right? Maximizing production.
100%. And that's now what I think partially what you shift to there is that, everybody's preparing their data set for AI. There's basically and we know that we're in a bit of a hype cycle, but it's real. I mean, I'm using this today and it's real. This is really like amazing productivity stuff. So, and we're also not necessarily, so we're talking prediction using machine learning models. And, that's different than AI. It's, it's getting from differential equations and linear regression more into, machine learning. But the idea of like being able to co-locate your supply chain data, your commercial data, and your operational data, and then to start being able to query that to say, how long did something last? Which one is running better than the other? Which one runs more cost effectively?
Right.
Which, I want to run valves through two different suppliers, and valves are obviously a long-term thing, but let's say something that is more that wears out more often, and it could be, I don't know, what oil am I using in a compressor, and how much more life do I get from it, and so now you can compare all these things in real time and see how you can optimize your cost centers and things like that coming into things. So I think that's the preparation, but again, it's like this walk or crawl. Crawl is, can I get the data from inside the fence to a place where it can be democratized in a cloud scaler type of provider? Then, can I visualize it? Now, who can I invite, right? So I was having a discussion with somebody the other day, and they're like, oh yeah, we're doing this startup and it's compressor. And so we want to get somebody who specializes in rotating devices, right? So compressors or pumps, whatever, right? And it's like, oh yeah, okay, great. But what you're going to end up buying is a fit for purpose, very narrow piece, right?
Right.
And you ask them, and they're like, well, we own Azure. So if you own the apartment already, why are you renting an apartment? Take the data there, put it in that site, and invite them to go build the machine learning models on top of it.
Yes.
And any property they develop, what they bring, they're going to own, but what they're going to develop, you end up owning.
Yeah.
Right? So why would you want to build your own competitive advantage by co-locating the data in a state you already have a negotiated license for?
Right. Yeah.
Versus buying something that's going to sit there, be standalone, and maybe, now we don't want just rotating equipment. We want something else that we want to analyze. We want to analyze something else. And all of those can be separate apartments in your cloud thing versus buying them all separately and then trying to figure out how to consolidate. So I think that's kind of like the thought is the ones who embrace this in the right way are going to have the competitive advantages, and they're going to be the ones buying the other companies because of that 2%, 4%, 6% improvement.
Well, and again, you're hitting on, you already have the apartment, you're already paying for the licenses on your side. The data is already there in the PLCs. And I know this sounds really complicated and expensive. And again, I come back to the ROI of it's not that expensive when you're, to your point, saving 2%, 4%, 6% on, profitability at the end of the day, because you're increasing production. That means you're making more product, you're wasting less product, and the reality is, okay, I have multiple assets. So now I have to do another standardization. And I say, no, you don't. I mean, I don't care if you have a Siemens here, a Schneider there, a Rockwell here, whatever, it doesn't matter. Again, democratizing your data means we can go in parallel without disrupting the existing control system, the existing operations. We can duplicate essentially that data path, pull it out and take it straight to the cloud in a secure one-way environment that doesn't mess with your existing operations. There doesn't need to be any outage, any downtime, any training for operations, any of that. Bring that data straight into the apartment that you're already owning and paid for, and then do something with that data that now can inform us what we need to do. And frankly, if you have multiple assets running on different control platforms and all of that, it's actually kind of a good thing, because now I can say, hey, coming back to oil and gas, those guys buy each other in circles, right? I mean, we just saw, the Chevron Hess transaction just finalized and a bunch of others, Hess has acquired others over the years. And so they have these pockets of assets that this field's running on this technology and this field's running on that technology. And eventually they do try to standardize and bring them together. And then someone buys the assets and that doesn't match that. And at the end of the day, it doesn't matter. We can pull the data out of all of that. And now we can compare. So if you want to do a justification of whether or not replacing that control system makes sense, we can do that. Or if you want to compare this region's using this platform or this hardware, and this one's using this hardware, or this one's using this sand provider versus this sand provider that charges 20% more, well, let's compare those basins and those providers, and shoot, maybe it's your hydraulic oil providers from one region to another region. Let's see. Is there a correlation there to say, yeah, paying 20% more is actually showing that we're getting 30% more lifetime out of our pumps? Maybe that makes sense now. Maybe it doesn't, right? But you got to start.
That was the whole synthetic, non-synthetic oil argument, was like, well, no, we've just always not used synthetic, but you end up finding that your equipment life ends up doubling. Right. And the maintenance periods go down by half. And yeah, you're paying more for oil, but like how much you paying for a compressor, right? Yeah. It's sort of the funny part of it. But yeah, anyway, so by going back to what you're talking about is, in the design, if you think about what's happening is you're not buying a specialty box to sit at the edge. You're going to bring the cloud gateway down to the edge. And right. You can run an industrial compute there, and you can hook up all of the pieces and all the data historians that are in that site to one. You can push your models down to the edge to look for anomalous data. But I think, so if we go back to the crawl, walk, run, and then ultimately fly, but that's, that takes a while, is get your data, connect it, lift it, start analyzing it, put it into dashboards and Power BI so that it can be drilled down in any way you want to slice and dice and see the data. Right. But the point being is that now when you start making predictions, depending on the risk of the system, you're going to develop the efficacy, like how valid was that decision. And also, if you look at like one of our partners, Gooder AI, Eric Siegel and his sort of machine learning AI book, it's like, when should I make a decision, right? So if in the example from his book, if somebody commits fraud, it costs $500. If you block a card and it's not fraud, it costs you $100. So now the model says that maybe it's fraud. Should I block the transaction or not? Right. So that is like getting down to the financial decision making of, this looks like it's going to fail. What is the mode of failure? Should I roll a truck? What's the cost of rolling a truck and replacing this now versus waiting and having a failure? Right. So now you get into real dollar value assessments of how you make your operational decisions. Right. So that's getting to the I built a model, it makes a prediction, I'm going to act on the predictions, and should I act on it? And what's the financial impact? And that gets us into the, basically run mode. Right. And when you then decide, well, I'm going to connect back because I've audited my system, I have enough security controls in place, and I'm willing to connect to the PLC and with the prediction, make a change to the output, speed or like you said, pressure. I see that there's a weather event coming. Do I want to run at a lower level so that my pressure is lower so that I don't end up flaring or something? Right. And in making that decision, at first you're just telling the human to go do that, and the human's verifying that it worked. But in the end, you're going to get towards automation. But that's really the end point. And I think people see automation as the fear of AI. And what I see it as is it's complementing humans to give them superpower to make decisions.
Yeah. Well, and to your point, once you're in that more walking stage, you can push that data down, but you can also run some of that. Now that we've optimized these equations and we're looking at things, we can start to see some of the trends to now run that model directly, locally on that facility And if you're really still concerned about it, then you don't connect it to the internet, but the model's on there, and we can go back on a, say, annual basis and in a safe manner push down a revised model if it changes. But you look at plunger lift and gas assist and even flares and things like that. I mean, if you can optimize, 1 barrel a day, if I can get 1 more barrel a day out of the ground at $60 a barrel, I mean, shoot, that's at least 365 times 60. I mean, that adds up to dollars, and that's for one field, one asset.
Yeah.
And, that alone pays for the service here, especially when you multiply it by 20.
You brought up a great point, and then go just one further. And I love the way that interrupting off each other like this is that you push your model down to the edge. You're isolated from the internet. But what happens is you have another model in there that's looking for anomalous data.
Right.
And if it sees anomalous data, it's going to push that up. It's still only one way because it's just pushing the data up. And you can operate the model can make the predictions and make the changes for optimization inside the firewall, and know that your attack vector isn't going to be from the your instant in the cloud to the edge, because you're firewalled and the model's running inside. But you still have real-time data coming up, so you can see all your operational aspects, any anomalous stuff you can see, right? So you end up with this mixed mode where I can isolate and run it and know that the attack vector isn't the data that's coming down to go make a change, because that's local. All you're doing is continuing to push the data up to make sure that my model is still relevant.
Right. Exactly. Yeah. Exactly right.
Fun. But let's, you've told me some stories about, networks and trying to rewire networks and prepare a lot of these, brownfield systems for modern data movements. What do you think? What do you see as the biggest challenges in a lot of that stuff?
The biggest challenge, I would say overall is knowledge loss in general. I'll kind of take it back to your 30-year guy that knows the thing's going to blow by the sound of it. Well, a lot of them know how things are supposed to be done, but the new workforce coming in don't know. They don't have drawings. They're trying to learn, and they don't know because they weren't there when it was built, right? Mm-hmm. So what we find a lot of times when we go out to facilities is the drawings are 30 years old. The programming logic doesn't match the way it was engineered in the first place. There's been so many changes to it over the years. We've actually gone in before and took as found logic from a facility, took it out and compared it to the cause and effect, which is what a lot of these facilities use to actually program the safety shutdown systems. And we found, a 4% discrepancy, which led to some high alarms not working, which could have caused a life critical and a safety critical event. And that was throughout their entire, field, their entire assets. We've gone into food and beverage manufacturers where people had shelved alarms that were actually there for protection, and they were working around safety interlocks, and they were working around, the lasers that, break when you put your hand in there for a safety shutdown. People work around all of that stuff, and then their drawings are out of date. They're not updating that information. And if you're not the guy on the site when that day happened, you don't know what's happening.
Yeah.
So that's always a starting challenge. So going in and first realizing that you need to network these systems, you need to get the updated documentation. Manufacturing and food and beverage in particular is notorious for buying a skid, a mixer, a conveyor, a whatever it is from China or, Asia more broadly, Europe, bringing it in and then installing it, powering it up, but it doesn't actually talk to anything. It's not actually networked. It's not actually visualized. And so when that one conveyor breaks, everything falls on the floor and the rest of the system just keeps going, and it just keeps throwing, product on the floor and mixing and burning. And, you talk about a pain in the butt is when you have to shut down an industrial oven that's baking bread, because when it's not at steady state, it's not cooking evenly, right? It's burning or it's undercooking everything. And that'll take a lot of time potentially to get it back to where the temperature and the gradients all throughout it is. So, what we see in the field a lot of times is the workforce that's starting to leave, right? their notes aren't clean, they're not taken, they're not written down. The new workforce coming in, I'll be kind of blunt, they're not as good working with their hands as the older generation that was out there driving tractors and fixing them on the farm, and they had to figure it out. A lot of them nowadays, a lot of us coming out of school and everything, I've never actually seen a resistor or, understand what, we've seen a motherboard, but I don't know what's on there kind of a thing. I've never soldered it together. That's the generation that's coming into these workforces. Yeah. So to understand how it works on the backside, some of these kids fresh out of school, they're terrified to open a electrical or control panel with some, understanding of why. Yeah, it can be dangerous, but they're afraid just to even open the panel, let alone, the older generation that would just open it up with, a cigarette in hand and a beer in the other, and they'd rewire the thing, right?
Put a nickel in there to bypass the fuse.
Yeah, the fuse isn't working, so go chew a piece of gum and put it in there. That'll work it out. They at least knew. I mean, it wasn't the right thing to do, but they knew what you could do, right?
Yeah.
And so the big challenge right now as well, I think that especially executives and plant managers and all of that are facing is we don't know how these facilities are wired. We don't know how they communicate. We don't know how they actually work. And God forbid a flare comes in and knocks us out because we don't know how to rebuild this facility as it currently stands because the prints are 30 years old or they were drawn by hand. I still see that so often in manufacturing and food and beverage. We find the prints, but they're literally drawn by hand still. In this day of, for 20 years, 30 years, we've been using CAD regularly, and I still see that other stuff. And it's not up to date.
Well, that's the reality, though, is your point is that, like, you're moving and you're always just, and I hear this a lot about, OT not having the budget and that, people want to embrace the OT IT because IT is going to bring a better budget to it and that type of stuff. But, I think to your point is that the reality of this brownfield piece and is like, you talk about the bread oven thing, where, okay, maybe the conveyor belt has no, communication, but we know it's a point of failure. So do we, use acoustic sound sensors to listen for bearings going out or whatever? So you can make sure that, you make that decision, but you're going to make sure that you understand it's a critical component and that you're going to monitor it. And it may take some retrofitting of getting a sensor in there that knows, like, hey, I'm listening for bearing failures. And one of my colleagues who helped found the company, Thing Zero, he worked in a large airport with all the belt systems.
Oh yeah,
right. And so I had gone to Denver last year, and my bag came back and it looked like it had been pulled behind a tow truck for about 200 months. There was nothing, and the ski boot. The heel of the ski boot looked like it'd been on a belt sander for like 15 minutes or something. Right? So the point being is these failures are real. They cause a lot of damage and inconvenience and all that kind of stuff. Yeah. And they have real costs associated with them. And so I think that's where you're not. What I found in manufacturing when I was there was you're breaking, like I said, this Pareto analysis down, and you're saying what's our highest thing, and working your way down the list. And that's the goal to successful, I think, change, is that it's that some people in the OT side are skeptical because they're like, data, cloud, all this stuff. Like, what are you talking about? That's got nothing about how we operate, right?
Yeah.
And my colleague, we would say anybody can look at 2 or 3 instruments or measurements at a time, but nobody can see 200 collectively and understand what that means, right?
No,
so that's the power of it.
Well, and I think the other thing you had talked about, okay, let's assume that there's an executive on the call here. They're looking to make waves. They want that 6% improvement.
Yeah.
Well, one of the spots that they could go and look first is go look at your facilities and look at every shutdown that was an unplanned shutdown, specifically just unplanned shutdowns. And what is the impact of that? Not just the revenue loss, but what did you have to pay for the emergency, the overtime rates, the overnight shipment for a $3,000 piece of equipment that's hot shotted, and you paid half of that in the hot shot cost, and the outage time, of course. You can add up these numbers really fast, but just looking at the hard costs of the labor and the equipment, the unnecessary hot shotting, those types of things, Now look at how much money you've spent on that, and then go back to your OT team and ask them, when you turn down that budget for the one updated controller they want this year, because they're currently buying most of them on eBay. Again, sorry to point fingers at manufacturing and food and beverage so much, but I routinely look at those facilities and they're still running on PLC 5s and Slick 500s, which, by the way, guys, those haven't been manufactured for over 30 years and your facilities are running on them, and your staff is buying them on eBay, open boxed, used, hoping they work and paying the expedited fee. And if it doesn't, well, then I guess we just wasted $1,500. We'll try another one, right?
Yeah.
Eventually there's not going to be another one, or the one they did buy isn't going to last more than 2 months. And so you look at those unplanned downtimes and how much money that alone is costing versus trying to do some of the proactive maintenance, predictive analytics, good best practices, visualizing this for your, not only your operators, but your operations staff, your facilities managers. And then again, at that executive level, what can you do if you can see in real time how much production you're going to make right now? For the last 30 days, you can see in real time how much you're making. Should we hedge our bets on the futures market with our commodities or not? I mean, that's the power of what can really be done here.
Yeah. No, for sure. And like you said, hey, when it drops down to $50 a barrel, just shut it in and do some work for a while, and then turn it back on and have it run when it's making 100, right?
Right.
The tanks are full. But anyway, look, it's what I really like about, working with Atlas, OT, is that it's like focusing on competency levels. It's same like working with Gooder or whatever. It's, we know that you've got trust and relationship that okay, we start working like with this one we're working with now with 7 plants. When we go to 100, we're going to have to retrofit a bunch of sensors. And how do I know that my partner, when we do that, we're going to set this up and that we're going to put together a roadmap together, and that you're not going to be like dealing with multiple vendors and not sure whether they're going to deliver their stuff or not, right? And so I think that's what's great about it. And I certainly appreciate that we're taking the time to go, figure this market out and grow it and look for areas where real impact can be made from the data. And so it's fun. Yeah.
I mean, one of my core philosophies personally has always been, it's a better world through better business, and you get better world, if all the business optimally, we're making better production, then the company's making more money, but we're making more product. If we can make more product at a better cost point, then more people can buy it. More people get that higher level of, standard of living. Job security comes with it, which is always kind of a upside down. People say automation's taking their jobs. Well, automation's doing the parts. Like you said, it's the superpower. It's enabling you to do more so that we can make better products, so we can make it more cost effectively. And all of us can have more of that, work-life balance and freedom to go travel and enjoy our lives, because it doesn't cost so much for milk and eggs, hopefully, right?
And maybe it's exciting to get up at 2:00 in the morning and go drive for 2 hours to go see what the heck's going on something, but
to go read a level gauge, right?
It's a lot more fun to, I think, to go look online and say, hey, looks like something's going to go on. Let's go fix this during the daylight. And then,
that's right. Yeah.
I remember one of my first jobs was doing mass flow meters, Coriolis, straight tube Coriolis mass flow meters. And it was water, you're looking at the water and oil concentration from all the various batteries so that you can back bill, because there were several owners coming into a single one, right? So, and I installed it and things weren't working properly. And the guy said to me, well, okay, I'll see you in the morning and it'll be working, right? So I had to deal with the UK. So I had a couple hours sleep, got on when the UK came online, walked through with the guy, with the programmer of like how to set it all up right. And then finished, I don't know, like 4:00 in the morning, ran back into the town, got a box of donuts. He showed up with donuts and he walked out and walked them through it all. So yeah, nice. Sometimes you have to do this, but the point of it is, as much as we can sort of, like you talked about, quality of life and balance, and I think the more we do this, the more predictable the systems become, and the less of this hair on fire type of thing.
That's exactly right.
Yeah. Yeah. So I think the only thing I'd like to close with really is just talking about this idea that you've got an idea and how do you make it a project, right? And I think a lot of people get focused on one part of it. And I want to say, I said in the beginning, is if you can take and spend a small amount of money on what does the plan look like end to end? What does the roadmap look? How do I build it and test it and understand what the impact of it is without a massive investment? So like Thing Zero, we built on top of Microsoft's platform a standardized OT operating environment that can be basically stood up to a client's requirement in a week to 2 weeks, start connecting data, flow it in, and understand what that is, and start then moving towards what does full-scale deployment look like. So it's just agile all the way and not worrying about starting because it's millions of dollars. Validate it and then come to your team, not with a theoretical idea, but look, here's the output of a POC, which cost me X amount of money. Compare, and I understand it's going to work. And that's how, when I saw that, in the long-term business that I was been doing in the past, that's why we ended up with people promoted most of the time because they took the time to sort of plan first, validate, and then go make a big, expenditure request.
Yeah. Well, and to your point, you're doing that on, again, the apartment that they're already owning that they don't even probably realize. There's a good chance people don't realize that they're already owning that. So that environment's there. So it's low cost already to do that proof of concept. On the facility side, again, the data is already there, whether you know it or not. You might need to aggregate it so that we can make that handoff, and that's the proof of concept. But let's just start with waste. I mean, that's one of the best success stories I can ever talk about. Is we had a client once, the very first thing we did day one was we started measuring their scales of their waste, just to begin to see how much are you actually throwing away. And then as the project progressed, within just a few weeks, we could show, hey, your waste is going down. We're already validating that you're saving money because you're not throwing so much away. Just that alone, I don't have any real analytics anywhere else. I just know the waste is going down, and that proof of concept paid for itself in almost real time, which then sets up what more can we do. That's when it gets exciting, right?
Yeah, for sure. 100%. Well, thanks very much for your time today. And we're going to hopefully get some people that they look at it and say, you're not completely wrong. There might be an idea that you had there that was useful for me. So we'll see how that goes. And all the best. And thank you so much.
Yeah, thank you. Appreciate the time.
Yeah, take care.